G'day guys, got a good one here for you. Those of you that are into the technical stuff, or you just want a bit of a laugh, this here is a GP3500, and it could be a GP Extreme, and it could be a 3000, it could be just what it is, GP3500. Now, with these detectors, they had basically normal mode and some other switch positions which changed the receiver position on time, and it gave it greater sensitivity to small gold, back to normal. But the timings, the sequential timings, the transmit pulses were the same, they never changed. But this one here, this is very interesting. This actually came in for a repair, but if you can see on the oscilloscope, I'll zoom that in a second. I'll just turn this on, and up go the pulses, and I'll just zoom in. I'll just keep zooming in till you can see it all. You can see the cursor sitting there. It's a little bit out of lock, but that's okay. Oops. Okay, I'm going to put this into 10 times. But even so, if you can look there, hopefully you can tell. Just ignore the cursors sitting there. Or I'll get rid of the cursors. We don't really need them, do we? Yeah, there we go. And of course, everything changes when you do that. We're missing a flyback pulse there. It's just the oscilloscope's not keeping up with it for some reason. I probably just got to adjust the hold off or whatever. But if you can see the lower part of that, all these GPs in normal timings have 3 pulses, which are about 35 microseconds long, and 1 big long pulse, which for memory is about I think it's 140 or 160 microseconds long. But we're looking at this one here. I'll just do some adjustments so I can get all the pulses up. Yeah, one lock up properly. I've got no idea why it doesn't want to show that. It should. I'm putting a high frequency now. Yeah, it just doesn't want to show the pulse. There is one there, believe me, there's one there. But as you can see on this one, it has 1 transmit pulse, another one, and another one. So it's got 4 pulses. But hang on a second. Go back this way. What's that tiny pulse there? I wonder what that is. You can see it there. I should have left the cursor on because we could have measured that, but anyway. We'll have a look at the what we got in the whole pulse stream there. Don't know if you can see that too clearly, but it looks like someone has had a go at putting an enhanced type mode into this detector. Now, the thing you might find very interesting is that if we look in here, well, I'll just turn it off. I don't want to blow it up after fixing it. But if you can, I'll have to undo all the wires because I won't be able to do this otherwise. I'll pick him up and I'll have to loosen that and put that down. If you can see in the middle there, in that brown holder, there is an EEPROM, and basically they put a socket in there, or this one could have already had a socket. No, I think a socket's been put in there. They had sockets on some of the extremes early on, and now they've, or someone's put a socket on there. And because these are EEPROMs that live in there, this GP series detector, I'll just zoom that out again, else it's going to be too blown up. Because it has an EEPROM, you can program your own timings into it. It's quite interesting because I've done that on detectors years and years ago. But it's interesting because we were putting, I think we're putting SD2000 4 short, 1 long pulses into other detectors at one stage. We had a switch, we could go between 3 and 4, or we'll be doing that on the SD2000, sorry, SD2200. It's a long time ago I was doing all this, sitting there and just coding the EEPROMs with the transmit pulses, which controlled everything in the circuit, by the way. Everything sensed where those pulses basically started and finished, and then would activate the receiver, multiplexers and that part of the circuitry after the transmit pulse. So yeah, someone's having an experiment by putting I think it's some of the GPX stuff into an old GP. Now, the interesting thing here, if you want to go and put a, I think the EEPROM, or you can use an EEPROM so you can reprogram it, of course. It's a 27C256 for memory. Well, it's written on that one there, but yeah, I can't read that small print from here, but anyway, that's what it is for memory. So if you want to experiment, you could get one of these older detectors, and it will do it if you program the correct code sequence into one of these, and just time it out, measure it up just so it loops. You can play around with it and try different timings. You could put in a whole lot of very, very small pulses as a repetition on to find very, very tiny gold. And by doing that, you could emphasize the samples as they overlay each other. You would get better signal to noise ratio on the tiny gold. And you could just use the address lines on the EEPROM there. It has address lines on it. If you actually look at, have I got one here? I probably have somewhere, but it's in bits. If you have a look at a, well, can you have a look at the back of this? Hang on a sec. Okay, I'll have to zoom in again for you. Okay, let's move that down. Oops, there we go. If you can see in here where these resistors are, you got 4 address lines there, and by putting a switch contact and pulling these to ground, it's a high value resistor. I think it could be 10K or something. Not off the top of my head, I can't remember. I'd have to go and poke it. But anyway, you pull these to ground. You can do it in each one separately, or you can do 2, and it will change, well, what you've coded into the EEPROM. It'll change the code, and you can have multiple switch modes just by addressing here. You put in a 4-position switch and you can go, I'll have that, I'll have that, I'll have that. So you can look at some of the later detector modes in later detectors, and you can experiment by just copying them out, just measure them time-wise, and program those into a EEPROM, put a socket on there. I think it might have a EEPROM on there. And with these things too, you can read the code out of them. They're not protected. So you can just read the code, see what you're starting with. I've done all this years ago. And I think I've got my reader and programmers out in the garage gathering dust and yeah, whatever else falls on them in the garage. But it's easy enough to be done. It's easy enough to be done. So you can do some interesting modifications to the older detectors. I've always said the older GP series detectors are a good building block. You can do all sorts. Actually, the SD2200 also, from memory, because I haven't seen one for a while, I'm pretty sure, because that's I've also done it with the SD2200, has a EEPROM as well, and you could flick out the EEPROM and put in some, I'll put in a socket. I'll just have a look here. I think I've got a stack of EEPROMs I've already done from years ago. I think they're in my drawers up here. I'll just have a look. Oh, look at this. I pulled the whole drawer. Oh, God, of course I have. The amount of stuff I've done over the years, I'll tell you. Now, I'll just zoom this back out again, and I'll tell you what we've got. Okay. I've got tape on stuff. It's all... Okay. That's the socket. You can see that. And I have EEPROMs here. Now, I'll read out what these are. Hang on a sec. I got so many. There's a whole series of these things. Okay. I've got OptPROMs, one-time programmable. So you program it and then you're stuck with what you've done. I was looking around trying to find my 4eyes so I can get a good view on these things and see what we got here. Okay, these ones I got from Rockby Electronics. They're Eugene. I'm giving you a plug. Okay, Rockby. Okay, these are, if you can read it yourself, NM27C256 V250. That's probably the time. It's transition time, I think. I think that's what it is for memory. Yeah, these are OTP EEPROMs, and that means that they're one-time programmable. And if you stuff it up, bad luck. But anyway, that's what they are. These ones here, let me have a look. Okay. God, I really can't remember on these. But a lot of this stuff is very hard to get. If you do want to get this stuff, contact Rockby Electronics. They have heaps of old stuff, old semiconductors, and sometimes it's just sitting there in bulk. It's really amazing what they have. He's been Eugene. I've known Eugene for years and years and years. I think probably one of his first customers when he was in Huntingdale when he first started. But yeah, we used to bulk buy surplus electronics, and he'd sell some, and I'd sell some, and yeah, whatever years ago. Yeah, so yeah, the MX27C256 QC-12. And these will handle up 12.5 volts too, by the way. It might be 12.5 volts the programming voltage. I cannot remember. Like I say, I haven't touched it. Oh, here's one. This is one I've probably done because I put it in this. This then goes into my programmer, and QC passed, really. That's just for this. I probably bought this on eBay or something, the holders. But yeah, you put them in that, program them, then stick them in the other socket. What else we got? Let's having a look at all these. I've got a bit of this stuff. Now I know I've got some erasable, UV erasable ones somewhere. These are Atmel ones. Yeah. So I nearly sneezed. Like I say, no edits. AT29C256. You have to look these numbers up. That might be a reprogrammable type. I really didn't want to do one-time burns because I was experimenting years ago. So I know I had some that were labelled, but yeah. Well, that's a big one with a window in it. Not that we were using it for this. I can't remember what I was using this for. I've got a few of these. I was programming something, but it is no joke. What is it? NM27C256Q. So I could have been probably using these and using an adapter board or something. Yeah, but you see a little window there. If that gets UV light on it, it's going to erase anything that was in that chip. So normally we put a little dot of blacked out paper or a piece of silver type paper over that to stop them getting erased. But who cares? it's old stuff. Yeah. So yeah, I was playing around with this years and years ago doing this, but it's funny, isn't it, that when you think about it, that years ago we were just mucking around changing the three short pulses into 4 short pulses and adjusting the large pulse to be mathematically correct for the ground balance. And yeah, I've never thought about getting the pulse code widths or something off one of the newer detectors like Enhance or whatever, and sticking it in one of these. But I tell you, you could try. You could have a look at the pulses that are generated by the GPX 6000 even, measure those out, program them into one of these chips, and just see if one of these detectors can handle it. I don't know. I never tried it. It might just be too short for these. I know there's a couple of little very short 5 microsecond pulses. These may not be fast enough to do it. You could experiment. You could reduce the capacitors on the filters to improve their response times. You could, I don't know what else you could do. You'd probably have to maybe change the damping resistor there into a different value. Yeah, I don't know. You could try it as an experiment, and then again, it might be too fast for your detector and it might blow it up. I don't know. I have never done it. But yeah, this one here definitely has had something like an enhanced mode attempted to be put into this detector. So, but what I should do is I actually should have a look and just see how good it is doing that. This is one we've modified a long time ago, and it's gone out to a customer, and the customer's gone and advanced on what we've done. Oh, dear me. Anyway, we'll turn him on, and there those crazy pulses have popped up. Yeah, it's interesting. Yeah, that very short pulse in there is not getting the amplitude you normally see on the flyback, so it's being limited somehow on the tiny pulse here. Actually, we should see how wide that pulse is. Oh god, I've got to do this again now. Okay, we'll have to increase that till I can see that tiny one. Where is it? There it is. I have to keep increasing. Okay, I can probably get in on that. Excuse my fat arm. Okay. Well, there's one there. Hang on a sec. Let's have a look at this. I'm pretty sure. What are we on? 5? Yeah. I'll have to go and change things around. So around about 22. There is a pulse there of 22. I can see it. That's on the 5 volt line, on the 5 volt transmit part of the circuit. And if we move along a little bit here, which I just bumped it, of course. Now, why is that there? There's a little tiny one there. Look at that. It's around about the 4.3, 4 or 5 microseconds. And that's on the 15 volt part of the pulse. Remember, Minelab called these dual voltage technology, which means 2 different amplitudes in the transmit pulses. It doesn't mean plus and minus 5 volt rails on the op amps. That was a joke. But anyway, yeah, so DVT, that's what it meant. It basically meant the long pulse, long duration pulses for big targets, and part of the ground balance circuitry is done on 5 volts, because I think 15 volts for 160 microseconds or whatever might have put too much stress on the transmit components, the power supply, and possibly even the coil would have saturated, but might have ramped up too quick. But yeah, that's interesting there. Where's our flyback from that? I really don't know what is going on here too much, because I haven't done it. I don't know. But yeah, you can see from there to there, that is definitely a 5 volt pulse. And then after flyback, it dips down. I don't know. Maybe that's someone's programming mistake. I got no idea what's going on there so quick after the event. That is, I wasn't zoomed in anyway, but I'll zoom in so you can see it. And I'll go put my pickup loop close to the coil. I could stick it on a transmit stage, but it works just the same if you put your, yeah, I'll just move this. It'll scream probably, but it'll probably go inverted, as it always does. Okay, that's probably a little bit better. Let's have a look now, see what's going on. Got a little bit more amplitude there. So we'll go back a bit and have a look. You can see that. It's probably got flicker because of different frame rates between the camera and the oscilloscope. But yeah, there's a little, okay. Now that I put it closer, the oscilloscope's now picking up the flyback pulse here for that little one. So I'll get onto that. Okay, well that one's 20. Okay, so that's a 20. This is interesting. I'm scratching my head here to what is actually going on. That's a long pulse here. There's a flyback you can see from that. But this little one here, which is what's negative dipping, it's very short, and I don't know why that would be like that. Oh, let me think. Let's have a think about this for a second. You transmit 5 volts, okay, but you don't turn your receiver on after that turns off. You then hit it with a very narrow pulse, Hang on, let's have a look at the pulse. Yeah, I don't understand this. I have no idea what's going on here. If somebody wants to elaborate, you can do so, because I would like to be enlightened. I don't understand. I'm going to get, there we go. This. 5 volts, bang, down, up goes flyback, and 15 volts transmit. Doesn't make any sense to me. I don't know, unless it was an experiment or something. But anyway, hey, I've got this thing on. Fairly quiet. I'll just hit it with my test targets, which, because I was doing tests, I've put them somewhere else. Hang on a sec, we'll go get those. Yeah, dear me. Okay, I've got my 0.05s and my 0.1. Okay, let's see what happens. Well, I can't overload it. That's a 0.05. It does work. Overall, the sensitivity to... What the hell is that? Oh, it's having a hernia. It's having a hernia. Jesus. Hang on a second. Something funny's going on here. Okay, what do we got on that? Okay. Okay. It's got variable frequency and variable gain on this detector. It's one that was done a long time ago, but look at it. Yeah. Yeah, it's got noisy all of a sudden. Okay. It's working better at the moment, but it's very jittery. But the big thing is, when you start mucking around with the different pulses, will it ground balance? Okay. Okay, it's in fixed. We'll throw it into tracking. It's trying to. No, it won't ground balance. That usually means that those timings are all up the creek. There's the mathematics to do the ground balance aren't correct between what's being generated. You really have to look at the original patents for the ground balance on this, and somewhere I found on the internet the actual mathematic equations for the ground balance are there somewhere. I don't know where they are. I haven't looked at those for years, but they were there. And if you actually base your pulse width measurements and programming with those, it will work. And you can even try fudge factors, plus or minus this and that, to see if you can get better ground balancing, better response to certain targets, negate detection holes in time constants. What else is there you could do? You can't really do too much in a cycle of pulses. The reason being is that for given targets, you really want repetition of pulses at the same duration to light the target up more, to get more samples on a particular target. If you start changing the pulses, you don't have as much sampling on that target. You've got two other little pulses that are partially sampling the pulses from the other bigger, the target that are getting hit by the bigger pulses. You may have an issue there in repetitive sampling, giving that target enough energy to light up. But then you've got the small pulses, that's doing a job on the smaller gold. You can probably get more of them in there for a given segment of that signal chain. But like I say, all this is experimental, and yeah, it's just my opinion, because I don't know. I really haven't done all that stuff, and I don't know if the detector will really handle it. But if you guys out there want to experiment, you can. It's not that hard to do. All you want to do is pop off the EEPROM or whatever's in there in the detector, and just read the code out and have a look at the structure of it. You'll see it's very easy. I think it's what is it from memory? It's so long ago since I've done it. I can't remember what the designators are. I think it might be crosses and zeros from memory, and the crosses were the on times and the zeros are the off times. Anyway, whatever it is, don't take my word for it. I haven't done it for what are we talking? I don't know. I haven't done that for about 25 years. I'm trying to remember about it, but it's a long time ago. All this sort of stuff was being mucked around with. I have had no reason to go reprogramming detectors, these old detectors. Just not lately anyway. In the past, yeah, we did do that sort of stuff, but yeah. But yeah, you could probably make up some nice little module and stick it in there now, and you could probably even control it by Bluetooth. Not that I would recommend, but you could do all sorts of things with these detectors. It's just a building block. If you look at these things as a building block, it's what it is. It's just, a couple of power supplies, receiver, a mux, transmitter. That's a little bit of energy recovery from the flyback. Goes back into the battery circuit. So a few interesting things there. It's also got pots on it. Don't go adjusting those unless you know what you're doing, because you'll make a mess. You got capacitors here in the filters. You can change the value of those. As long as if you change a bank of those, you want to keep them all the same value. I can't remember what they are. I think they're, where are they? There's caps near the pots. I think they're all 10 nanofarads. There's some up here which are, what are they, 16? And if you want to detect them more smooth, we change those to 32. If you want it more sharp and punchy, you can drop them to half the 16s and drop them to 8. It might be too noisy. I haven't done that stuff for ages. That's old hat, doing all that sort of stuff. There's much more gain to be done lowering the noise figure and getting the noise out of these things. Just get the noise out, then you can hear the targets. But you can still play with it. You get in there and play with it. You might come up with some fantastic innovation. You could do all sorts of things. You could put another series of opposite polarity MOSFETs in there for another power supply, and you could run bipolar pulses. Ooh, you could do anything you want. That'd be interesting, wouldn't it? You also then have to deal with it with the receiver too on both pulse excursions. That'd be interesting. But yeah, like I say, treat it as a building block. There's plenty of even an old, I'm saying there's a heap of knockoff copy SD2000s out there. I've seen them. They're all over the internet. You could pick up one of those old, or one of those newly designed ones. I suppose we'll call it newly designed. Well, it's just a knockoff, isn't it? It's much the same design, but yeah, you can basically guarantee that the patents covering the SD2000 have well and truly expired. But you can just redo all the artwork so you don't breach copyright and come up with, just modernise the hell out of it. You can do a very, very good modernisation job. I haven't really seen anyone do a proper modernisation job on an SD2000. They sort of try and utilise the old componentry, and it's got all sorts of weirdo chips in it. Like what were they? LM3, what are they? 3.6. I can't know. I can't remember the numbers. Too long ago. Like, I haven't mucked around with that stuff for yonks. LM 1300s and stuff, or 1600s. Transconductance amplifier chips. I mean, fair income. And that was, just voltage to current converters. That's how they did the audio. But back then, that's what they did. Now, you wouldn't do that in a fit. But, as a building block on the basic circuit, you can modify the hell out of it. You could do a hell of a lot to it. You could even run a couple of supply rails in there and change it to dual voltage technology if you wanted to. You can do all sorts. That's only if it doesn't breach any outstanding patents, of course. I better put that disclaimer in there, or else I'll have that evil witch doctor bone pointed at me. So only if it doesn't breach any existing patents that you can play around doing that. And that was easy. Just long pulses. Well, the long pulse was done at 5 volts and the others were done at 15. Well, if you want to get really complicated and that, how about do your long pulse at 10 volts and do the others at, 30? Beware of the smoke from the overheated output stage going into such a low impedance coil that at DC looks like a dead short circuit. But I mean, when you start switching, it's totally different, of course. But you can play, and you got to be careful. So, by saying such things, what am I doing? Am I causing people to start experimenting and go into their own detector manufacturing? I don't know. But it's worthwhile experimenting with these old things. Probably so much easier with a single board design than this pile here. But you can do it. You could just just think about the basics of the metal detector. It doesn't have to be one of these. It can be anything. You could get some, what are they called, Surf Pro or Barracuda or something. One of those designs that are out there. You could probably find them on the Geotech One forum, geotech1.com, and go and annoy Carl. And he's got a lot of circuits up on his website. You could utilize that. And there's people there who sell boards and stuff as well. You get a circuit board, make one up. There's probably people who sell made up ones. But those things, you get the schematics and that, you can experiment and do add-ons and try different things. Where these are a little bit more complicated, it's a bit more cramped up. You look at the boards on this and it's, got to get right in there. It's all cramped up. But you can play, and you never know what you come up with. But on these, you can just do the EEPROM. It's easy enough. Well, if you know what you're doing, programming, anyone out there who's had a bit of programming experience, get a programmer, go for it. Anyway, that's enough of that. But I just thought this was funny with the funny pulses in there. Yeah, it's not my doing. Anyway, catches.